Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 2977 minimum cost to convert string to. Okay, this is an extension problem to the yesterday's Leetcode problem. If you have solved the yesterday's Leetcode problem, it's well and good. This is a little advanced problem compared to the yesterday's problem. Okay, so let me explain you briefly what the problem statement is. Okay, so we have been given a source string and we have been also given a target string. Idea is to convert the source string into the target string. Okay, and we have to do it with the minimum cost. Okay, so we have been also given an original array and the changed array. Okay, it contains strings original and changed array and cost, all these three arrays of same length, and the cost required to convert original of ith string to changed of ith string is basically cost of I. Okay, if I have to convert fgh to thh, the cost will be 3 rupee 3. Okay, to convert this string into this will be cost of 5. Okay, I'm back uh, to my iPad screen. Okay, so if you see, these things can be mapped into a graph, like as it is similar to the yesterday's problem itself. So I have converted the original and the change and the cost into a graph with the corresponding edges. Okay, so we have been given an original array with BCD, FGH and THH. So BCD is connected to CDE at the cost of with the cost of 1. FGH is connected to THH with a cost of 3, and THH is connected to GHH with a cost of 5. Okay, now we have to convert the source into target. Okay, so let's take a particular index. Okay, now for a given index there are two possibilities primarily. Either the character at the ith string, character at I in the source will be equal to the character at I in the target. If both the characters are same at a given position, that means I don't have to convert this. I have to check whether I can convert the rest of the things or not. If yes, what is the minimum cost associated? Okay, if the character at I does not matches, then I have to check whether the source starts with any of the strings present in original array or not. Okay, if the substring from I till end, if it starts with any of the substrings, that means there's a possibility that I can convert. Okay, I have to check whether it is feasible to convert these strings to any one of its target string or not. If yes, then what is the cost associated to convert S to T, where T is basically the substring from ith index till which is same as the length of S. Okay, let's say I have chosen, if the source at I starts with BCD, that means I have to take a substring from our target which is of same length, which is of length 3, and I have to check whether BCD can be converted into this target or not. If it is convertible, then what is the cost associated to convert it? Okay, and the overall cost will be the cost associated to convert S to T plus cost associated to convert the remaining string. So let's assume that we have a function called minimum cost, which will tell me the cost associated to get the cost to convert the remaining string. Okay, so the remaining string would be starting at an index of I plus the length of the string. Okay, so what we will do is, we'll just write a function called minimum cost, which will start at index 0. What we'll say what is the minimum cost to convert the source to target right from index 0 till all the way till the end. So at each position we check whether these two conditions are satisfying or not. If any one of this condition is satisfying, then we'll calculate the minimum cost accordingly. Okay, so let me jump back to the code and let me show you how I've implemented it. Okay, as I mentioned, we are converting our original and changed and the cost into a graph. So we will be having an adjacency matrix where I will be having a key as one of the string from the original array, and I will be having a list of strings. Okay, so let me just show you over here. As you can see, this is adjacency matrix where string and corresponding neighbors. Okay, and I also have a map called distance map. So what I was doing is, here if you see, I was supposed to calculate cost to convert S to T. Okay, so instead of applying Dexter algorithm at for each source and T, what I will be doing is, for all unique strings in the original array, I will be applying Dexter algorithm to find the shortest distance to all the neighbors. That is what I have mentioned here. Okay, as you can see, this is a minimum I will be applying Dexter algorithm on all of this. Okay, so let me jump back to the code and show you. Okay, so distance graph will contain, for a given source, it will contain the shortest path to all of its destination nodes. Okay, yeah, so I will just define global few parameters which I am mapping to it, so that I won't have to pass to my function. So I just define source, target, original, change and cost, and I will just map all of them to the class variables. And then I've also defined adjacency matrix, which I mentioned to generate the adjacency matrix of the graph, and distance map I've already explained. So initially I was just mapping all my original change and cost into, I was converting original change and cost into my adjacency matrix. So the adjacency matrix does not contain a particular string, then I was creating a new list and then adding the change as a neighbor to it with the cost of I. So I just defined a class called pair, which will be having the neighbor and the corresponding cost of it. Okay, now that I have populated my adjacency matrix, I will be taking all the unique elements from my original array and I will be applying Dexter algorithm on it. Okay, as I mentioned, right, I have to apply Dexter algorithm. So let me jump back to the Dexter algorithm. Okay, as you can see, for a given source, I have to identify the shortest distance to all of its destination nodes. So I just defined a distance map saying that from the given source to its destination, what is the cost associated to it. So that is what I will be storing in this, and I will be returning it. Okay, so as we all know, Dexter algorithm works on in a greedy fashion. So I just defined a priority queue which will take pairs and then return the minimum pair always. Okay, so when in the initial setup, I was just offering my start with a cost of 0, because the cost associated to reach start from itself is actually a 0. So that is what I have done here. As long as my queue is not empty, I will be polling the element from the queue and check whether the distance is already calculated or not. If the distance is already calculated, then I don't have to do anything, I will just continue, or else that means I have identified the shortest distance to my destination node, the current destination, and then I will be updating it in my distance map. Okay, so for all the neighbors of the current destination node, I will be calculating the new cost associated to it. The new cost associated will be cost associated to reach to the current node and the edge weight basically. So that is what I'm offering. Once this entire algorithm is run for a given source, we will be having all the minimum cost associated to reach the corresponding destination nodes. Okay, now that I have calculated the cost associated to reach all the destination nodes from all the source nodes, now I have to identify the minimum cost to convert the source to target. Okay, so I will be as I mentioned, I will be writing a function called minimum cost, which will be taking the 0 as a start index, which will tell me the minimum cost associated to convert. Okay, this will tell me minimum cost to convert source of I till end to target of I till end. Okay, so once I've reached end of my source, okay, once I've reached end of my source, that means there is nothing to convert, so I will be returning a cost of 0. Okay, and then my result, I'm just define a variable called result. If I'm not able to convert a source to target, then I will be returning a very large value Okay, so as I mentioned, there are two possible cases. Okay, whether the current character matches. Okay, if it matches, if the source, the character at I in the source, if it matches with the character at I in the target, then I have to identify the cost to convert the rest of the string, which is from I plus 1 till end. So thus this function will basically give me this result. If this is one of the possibility, not necessary that this will correspond me to the minimum cost. Okay, so I should also go to go through all my original distinct elements in my original. Okay, so distance map will basically, key set will basically contain the unique elements from the origin. Okay, original. And then if my string, if my source, if the source starts with, if the substring at I in the source starts with any one of the string in my original, that means I have to convert that source into the corresponding target in from I till I plus length of the current source. Okay, so I just defined, if the source starts with S, then I will be converting it into target, which is of length substring from I till I plus length. Now that I have to check whether what is the cost associated to convert the source to target, so that I can get it from my distance map. Okay, now if I am not able to convert it to a target, then I will simply continue. If I'm able to convert it, then I have to identify what is the cost associated to convert the rest of the string, which is from length of I plus length till all the way till the end. So this will give me the cost associated to convert the rest of the string. So the overall cost will be the converted plus rest. So that is what I am updating in my result. So since this is a recursive solution, there will be, if you draw the entire tree, you will identify that there will be some states which are actually repeating. So we have to apply memoization. So that is what I've done. I've just defined a DP array which is of length equal to the length of the source, and then I've just initially filled with -1, so that I know that the minimum cost is not calculated yet. If it is not equal to -1, that means the cost to convert the source from I till n is already calculated, so I will not recompute again, I will just return it. Okay, and then I'm just updating my DP of I as well. So if I try to submit this problem, as you can see, all the base test cases were passed. If I also try to submit this, all the test cases will also pass, and this is pretty efficient solution. So if you're new to the channel and if you like the explanation, I highly recommend to subscribe to my channel so that you won't be missing the content which I will be posting on daily basis. Also provide me your valuable feedback in the comment section, and don't miss to hit the like button and subscribe button. Thank you.